Welcome to Math for Trades. Today we're diving into measurement systems, specifically looking at how we measure length and weight in both metric and imperial units.
In the trades, you'll encounter two main systems of measurement, the metric system, originating in France, and the imperial system, developed in Britain. The metric system is a decimal-based system, meaning it uses multiples of 10, while the imperial system is based on historical, customary units. Let's start with linear measurement. This is simply the measure of length or distance, a single dimension. Whether you're measuring a piece of pipe or the distance between two cities, you're using linear measurement. We use units like meters and centimeters in metric, or feet and inches in imperial. The beauty of the metric system is its simplicity. Everything revolves around a base unit, in this case, the meter. For instance, the prefix centi means 100th, so there are 100 centimeters in 1 meter. The imperial system, on the other hand, doesn't use a base 10 structure. It relies on specific conversion factors between units.
You have to remember that 1 foot is 12 inches, 1 yard is 3 feet, and a mile is 5,280 feet. It takes a bit more memorization.
Because Canada uses metric officially, but trades heavily with the US, tradespeople must often convert between the two systems.
Knowing key conversion factors like 1 inch equaling 2.54 centimeters is crucial for accuracy on the job site. Moving on from length, let's talk about weight, or mass. While technically different in physics, in the trades we generally use the terms interchangeably. Just like linear measurement, metric weight uses a base unit, the gram. The prefixes work exactly the same way. A kilogram, therefore, is simply 1,000 grams. It's a consistent, logical system. Imperial weight measurements are what many of us use daily. The key units are ounces, pounds, and tons. Remember that there are 16 ounces in a pound, and an imperial short ton is 2,000 pounds. Next time, we'll look at how to convert these weights. Moving right along, let us apply our conversion skills to weight. In the trades, you will frequently need to translate between imperial units like pounds or ounces and metric units like kilograms or grams. Whether you are calculating the weight of a heavy welding machine or measuring flour for baking, setting up a simple ratio is your best tool. Now, let us switch gears to temperature. Unlike heat energy, which measures quantity, temperature gauges the intensity of heat. In Canada, we primarily use Celsius, while the US uses Fahrenheit. But there are also absolute temperature scales, known as Kelvin and Rankine, which are crucial for certain scientific and engineering applications. These absolute scales start at absolute zero. This is the theoretical temperature where all molecular movement completely stops, meaning absolutely no heat is generated. On the Celsius scale, this happens at -273 degrees. The most common temperature calculation you will make is converting between Celsius and Fahrenheit. The formula is straightforward. Multiply your Celsius temperature by 1.8 and then add 32. The 1.8 is simply the ratio of the difference between boiling and freezing points on both scales. Next, we need to talk about pressure. In physics and the trades, pressure is defined as the force exerted by an object per unit of area. You might be familiar with pounds per square inch, or PSI, which we use for things like inflating tires or measuring water pressure in a pipe. But PSI is not the only unit. We also use metric units like the Pascal, or specialized trade units like feet of head or inches of water column. For instance, a column of water 2.31 feet high exerts exactly 1 psi of pressure at its base. Because different trades use different units, you need to know how to convert them. The easiest method is to use 1 psi as your home base. If you need to convert from feet of head to inches of water column, you first convert to psi and then to your final unit. This prevents you from having to memorize endless conversion factors. To wrap up this segment, we are going to look at equations. If I ask you to solve 5 plus 4 times 3, you might get different answers depending on which part you calculate first. To prevent this chaos, math has a strict order of operations we must follow, which we will break down completely in the next section. Now, let's move on to transposing equations using multiplication and division. The core principle remains the same as with addition and subtraction. Whatever operation you perform on one side of the equal sign, you must perform on the other to maintain balance. This is the golden rule of algebra. It ensures that the equation remains a true statement throughout the solving process. Before we dive deeper, let's refresh our memory on reciprocals. A reciprocal is simply a number that when multiplied by another number results in 1.
For instance, if we take the number 4, which can be written as the fraction 4 over 1, its reciprocal is 1 over 4. When we multiply them together, the result is 1. This concept is crucial for isolating variables.
Sometimes the variable we need to isolate is stuck in the denominator, like d in this equation. Our goal is to get d by itself in the numerator. A handy trick is to flip both fractions entirely. If the original equation is true, then flipping both sides will also result in a true equation. Now, d is in the numerator, making it much easier to solve. Let's apply these rules to a real-world formula, the area of a circle. The formula is area equals the diameter squared times 0.7854. Our task is to transpose this formula to solve for the diameter, d.
First, we need to isolate d squared. We do this by dividing both sides by 0.7854. This leaves us with d squared on one side and the area divided by the constant on the other. We would then use square roots to find d, which we'll cover later. We will be transitioning into a new topic now, calculating perimeter. Perimeter is simply the total length of the continuous line forming the boundary of a closed geometric figure.
Imagine walking along the outer edge of a shape, like a baseball field or a room. The total distance you travel is the perimeter. This concept is fundamental in many trades, such as calculating the amount of baseboard needed for a room.
Let's look at how to calculate the perimeter for squares and rectangles. Since perimeter is the total length of the boundary, we simply add the lengths of all the sides together.
For a square, since all sides are equal, the perimeter is the sum of its four sides. For a rectangle, we add the two lengths and the two widths together. Understanding what the formula represents is often more helpful than just memorizing it.
Moving right along, let's shift our focus from the outside edge to the inside space. Area is defined as the amount of space inside the boundary of a flat two-dimensional object, like a square or a circle. To calculate the area of these shapes, we use the same dimensions we used for perimeter, but instead of adding, we multiply. For a square, the area is a side multiplied by a side. For a rectangle, it is the length multiplied by the width. Keep in mind, because we are multiplying two one-dimensional measurements together, our resulting units are two-dimensional, or squared. If a square has 5-inch sides, multiplying 5 by 5 gives us an area of 25 square inches. Triangles are a bit different because they only have 3 sides. To find a triangle's area, we need to identify its base and its height. If you picture two identical right triangles put together, they actually form a perfect rectangle. Because a triangle is essentially half of that rectangle, the formula for its area is simply the base multiplied by the height, all divided by 2. This mathematical rule applies to any triangle, as long as you measure the correct base and height. Now, circles don't have straight lines, so we use the radius or diameter. Here's a fascinating fact. If you place a circle perfectly inside a square, the circle takes up exactly 78.54% of that square's total area. That gives us a very handy trades math formula. The area of a circle is the diameter squared multiplied by 0.7854. You can also use the classic formula, pi times the radius squared. We will carry these area calculations with us as we step into three-dimensional volume next. Let's move right into cylinders. Think of a hot water tank or a large grain silo. A cylinder is essentially made up of a circular top, a circular bottom, and a middle section that connects them. To figure out how much a tank like this can hold, we need to calculate its volume. Since the top and bottom are perfect circles with the exact same area, we just need to find the area of that circular base and multiply it by the height of the tank. Here is the standard formula you will use. Volume equals the diameter squared times 0.7854 times the height. Multiplying the diameter squared by that constant gives us the area of the circle, which we then multiply by the height. A quick warning about units. Before you plug numbers into the formula, you have to make sure your variables match. If your diameter is in millimeters and your height is in meters, you must convert one of them so they are the same. Once your units match, you can calculate the volume. Because the diameter is squared, you are essentially multiplying 3 dimensions together, meters times meters times meters, which results in an answer of 1.91 cubic meters. What if we needed that answer in cubic millimeters? It is not as simple as multiplying by 1,000. Since volume is 3-dimensional, a 1 meter cube is 1,000 millimeters long, wide, and high. Therefore, 1 cubic meter is actually equal to 1 billion cubic millimeters. To wrap up our module on volume, remember that calculating volume always involves 3 dimensions. Always double-check that your units match before doing the math, and remember that your final answer will always be expressed in cubic units.